So now I need to find a common denominator to be able to subtract here. I end up with 8 halves minus 7 halves for a y-intercept of 1 half. And those are the two values that I need, my slope and my y-intercept. And now I can plug into my general form of y equals mx plus b. So there's your equation in slope-intercept form for example 3b. I'd like you to now attempt guided practice 3a in your textbook. Write the equation in slope-intercept form, and then go ahead and graph it as well. And again, we'll take a look at that together Monday in class. Okay, just like with slope, we had special cases with horizontal and vertical lines. We also have special cases as far as the equations. Excuse me. We also have special cases as far as the equations of horizontal and vertical lines. And that's because of really the special slopes that they have. So basically, a horizontal line is always going to have this general form where you have y is equal to some number, and that some number is going to be the y-intercept. Okay, so we just go straight to whatever this b value is. In this particular example, that b value is -3. We plot a point at -3 on the y-axis, and then we draw a line through that point, and that's our line. Vertical lines are very similar. We have x is equal to some value, where that value represents the x-intercept of the line. Okay, if a y-intercept is where a line crosses the y-axis, then an x-intercept is where a line crosses the x-axis. So now we go to whatever the value is on the x-axis, plot a point, and draw a line through that point. Okay, so those are your special cases, and it would be in your best interest to just remember, if you have y equals a number is horizontal, if you have x equals a number is vertical. I know it seems a little backwards with your x and y axis, but it's the way it is. And so let's take a look at some examples with slope-intercept form dealing with horizontal lines. Okay, what you're given here is no different than what you've been given in example 3. You have 2 points, and you're asked to write an equation in slope-intercept form. And well, like I said before, we can always take those 2 points and use the slope formula, right, to find the slope. But my slope is going to end up being 0, okay, which makes sense because your y values are the same. So if you notice that, then you can really skip that step. If you don't notice that, okay, then you're going to end up with a slope of 0, and at that point, you don't really have to do anything else. And I see in this particular example from the book, they're writing in point slope form, and they go through all these steps in step 2, but we've already talked about the fact that all horizontal lines have a slope of 0. So once I get a slope of 0, I know I'm dealing with a horizontal line. And I know that a horizontal line has a general form of y equals b, where b is the y-intercept. Okay, and here is your y value for every point on the line. And just because they didn't give you the intercept doesn't mean that you don't know where this line is going to be. Okay, every single point on a horizontal line is going to have the same y value because it never moves, right? So if I have a point at 2, 6 and a point at 5, 6, right, then I'm also going to have a point at 0, 6 and -2, 6 and negative infinity 6. Every point on the line has the same y value. So if you have one y value, then you've got them all. Okay, so going back to our example, once we determine that it's a horizontal line, well, now we just look at our y values that we're given, and that is the value we plug in for b for our equation. And the same goes for vertical lines. If you were given, say, these 2 points, 2, 4, and 2, -7, and you were asked to write an equation in slope-intercept form here. Okay, well, I would first go about finding the slope, or notice that I have the same x value. Okay, well, what's going to happen when I find the slope is I'm going to get an undefined slope. Okay, and I know that undefined slope means that I have a vertical line. I also know that the general form of a vertical line is x is equal to some number, where that number represents the x-intercept. So I would go on my graph to where x equals 2, and that's where my vertical line would be. So just like every y value was the same with horizontal lines, now every x value is the same with vertical lines. So if I have one x value, then I've got them all. And so they gave me the x values here and here. The equation would be x is equal to +2. All right, last example. Going back to the parallel and perpendicular lines, that's not going to go anywhere. We've still got to remember that parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. So if I am given to write an equation in slope-intercept form for a line perpendicular to this line and containing this point, well, let's think about the things that I need to write an equation in slope-intercept form. I need the slope value, and I need the y-intercept value. Well, if I want a line perpendicular to this line, then I already have the slope, right? And that's what they're telling me here. I have a slope of -3 given, and I know that the line perpendicular to it has to have an opposite reciprocal slope. So I take -3, I flip it to get 1/3, and then I make the negative a positive. Okay, so there's my slope of my new line already. I didn't have to do any work for that. And then I have the point that it has to go through, 4, 0. So I take that information, I plug in the y value, I plug in my new slope value, where it goes, and then I plug in the x value, just like I did before when I had a slope and a point. I multiply 4 and 1/3 together, and then solve for b. So I've got my y-intercept here, and I've got my slope here, and now I can plug those in where they go into the general form. Y equals mx plus b. And where you can have a mixed number, or you can have an improper fraction. I would actually prefer the improper fraction, and I would also prefer that we write it as subtraction instead of plus a negative. Okay, so y equals 1/3 x minus 4/3. So your last example to do on your own, I would like for you to try guided practice 5. Write the equation in slope-intercept form that they ask you to write, and then plot the line or graph the line. And remember, when we are graphing a line in slope-intercept form, we first plot the y-intercept and then use our slope. so you have 3 examples that I've asked you to do on your own paper that we'll talk about in class on Monday. Guided practice 2, guided practice 3A, guided practice 5, and then there's also a short quiz that will be attached to the videos. Same way as last time, where you click on it and then enter your name and the class code. And we'll talk about all of those things in class on Monday. Hope you have a great weekend, and we'll see you on Monday.